What we mean by measures of dispersion, we talked about measures of central tendency. Well, what does disperse mean? You disperse something, means spread out. So what these are going to measure how spread out data are. That's what these next few measuring devices are all about. How spread out they'll measure how spread out the data is. That's what dispersion will measure, okay? Because here is why we might need to talk about such a measure. Because if I have, say I have two distributions here, A and B, and distribution A has these values, 5, 6, 7, 8, and 9. B has 1, 2, 7, 12, and 13. Somebody tell me what X bar is here, the mean. What's the mean of A? Well, the mean of A would be, take the numbers, total them up, 5 plus 6 plus 7 plus 8 plus 9. 35 is the total of those. Divide by how many? 5? Gives me 7. All right, so the mean of A is 7. What's the median of A? What's the median here? The mean is 7. What's the median? Also 7. It's a little different calculation. The median is just the middle value. Okay, and it doesn't have a mode, but the median is 7. The mean is 7. So that's what we got for that one. What about B? What's the mean X bar of B's values? Well, add up those values. You got 1 plus 2 plus 7, 12, and 13. That gives you 35, doesn't it? Divide that by 5 values. That's 7 also. What's the median of B as well? Isn't the median 7? Middle value is 7 also. Okay, so here's my point of this. A and B both have means and medians of 7. However, they're two totally different data sets, aren't they? I mean, this one is different than that one. But they have the same mean and the same median. Well, what is something different about A and B? Well, wouldn't we say A's values are more close together than B's are? Wouldn't you say that? A's values are closer together than B's are? In other words, they're more dispersed, okay? B's are more dispersed, right? A's are less dispersed. B's values are more dispersed. So what we're going to talk about next, two different measures of dispersion that'll tell us that, hey, yeah, these values are more spread out than these values are. And we can do that without even having the values here. But the point is, you know, these just tell you a middle value, and it doesn't tell you necessarily much other than that. But these next two measurements are going to be dispersion, tell you about dispersion. Okay, the first one is the range. And it's the easiest one, kind of like the mode. The range is, just take the largest minus the smallest value. They said that's pretty easy. Just take the large value minus the smallest value, okay? So what would the range of A be? Well, you take 9 minus 5, right? It's 4. The range of B, well, that's 13 minus 1. That's 12, isn't it? So A's range is 4, B's range is 12. Yeah, B obviously has more gap in between it. Okay, so that is one measure of dispersion. Now, however, let me tell you, that's a nice, easy calculation. However, it is limited statistically speaking. It's not used just a whole lot for much of anything, but it is a nice calculation. The reason is, you might can see here that the reason the range is kind of a limited in its usage because really you're just dealing with the first value and the last value, or the highest and the lowest. You're only dealing with those two values. Well, you know, a distribution, these just have 5, but what if I had 20 values? On the range, I'm still only looking at the largest and the smallest. I'm only dealing with those two values. Even if it has 1,000 values, I'm only looking at the largest minus the smallest. What about the ones in between? How many are closer to the largest? How many are closer? It doesn't matter on the range. So it's limited to what, statistically speaking, you can do with it. So we'll calculate it, but we'll use the next one a little more. Number 2 is what's called the standard deviation. It's the more, dare I say, important of the measures of dispersion. Yeah, a little more widely used, let's say it that way. Okay, so standard deviation is a measure of dispersion. Here's how it works. Well, notice there it's standard deviation. So let's start with just deviation. What we mean by deviation is deviation from the mean. For a particular value. How far is it, in other words, from the mean? What we mean by deviation is how far is it from the mean. Okay? For example, let's put up here 5, 6, 7, and 8, and 9, the A distribution here. And below each one of these values, I'm going to put the deviations. For example, 9, the deviation of 9 would be, how far is it from the mean? The mean is 7, so 9 is 2 away from the mean. So the deviation of 9 is 2. So that's, what about 8? What's the deviation of 8? It would be 1, because it's 1. The mean is 7. 8 is 1 away from the mean. Okay, so that's deviation. Now, if I wanted to put that in a formula, what is the formula for deviation? The formula for deviation is you just take the value and you minus the mean, right? So I took 8 minus 7. So it's deviation is value minus the mean. Now that's significant here because when I come to 5, what's the deviation of 5? Well, if I do 5 minus 7, what do I get? Negative 2? Yeah. The deviation of 5 is negative. Why is it negative? Because it's below the mean. The numbers below the mean are always going to have a negative deviation. So 6 is going to be a negative deviation. What is 6? Negative 1. With me on that? What about 7 now? What's the deviation for 7? Deviation of 7 is 0. 7 minus 7. So the deviation of 7, because it's the mean, it's 0 deviation from the mean. Okay, so that's deviations. I want to do, though, standard deviation. Basically, the idea for standard deviation, you want a kind of an average. See, we've got 5 deviations here. What standard deviation tries to do is kind of give you an average of these deviations. See what I'm saying? This is, this one's this many away, this one's this many away. So standard deviation is basically an average. Now, it is not, though, the strict average of the deviation, because you notice what happens if I try to average these. Add them up. Negative 1 plus negative 2 plus 0 plus 1 plus 2. What would that give me? That would give you 0. And that will always happen on deviations. If you add them up, you get 0. So you average them, you get 0. So that's not going to help us much at all by just averaging them. But here's what we're going to do. To kind of get around that, to compute the standard deviation, let me erase that. Well, what I'm going to do is the deal is the negatives cancel out the positives. So one way I can get rid of the negatives is to square the deviations. So next line here, this is how we're going to kind of set up the standard deviation work here. Is the next line is we're going to square each deviation. -2 times -2, -1 times -1, square each one of them. That's 4. -1 times -1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. So square each one, because when we square a negative, we get a positive. So now they don't cancel out, you see. Okay? So get your deviations, then do your square deviations. Now we can talk the standard deviation. Here it is. First of all, letter designation for standard deviation is S. See S, that usually means in statistics, means standard deviation. Here's how I'm going to compute the standard deviation. I'm going to take and add up all the square deviations, sum of all the square deviations. Going to go on this top line. Once I square them, then I'm going to add them up. Now, what I'm basically going to do is average these out. So when I average something, you know, I add them all up, and then I divide by what? The total number there are. Now, there's a little catch on standard deviation. It turns out to get this, see, this is usually a sample, so to get this sample standard deviation to match with the true standard deviation of the whole group, you have to divide by not n, but n minus 1. And what's n again? N is the number of values there are. So I'm going to take the number of values minus 1. So if there's 10 values, I'm going to divide by 9. If there's 11 values, I'm going to divide by 10. Here there's 5 values, so I'm going to divide by 4. Okay. All right. So that'll get me my average. Now, the thing of it is, I want the standard deviation. This is kind of the average of the squared deviations. So to get back to just deviations, wouldn't I have to square root? See what I'm saying? So that's the last part of this. Just kind of understand where all this comes from. So you do the square, you add all these up and divide by how many there are minus 1, and then square root that. That is called the standard deviation. Now, what is it in this case? Well, it's going to be the square root of 4 plus 1 plus 0 plus 1 plus 4 divided by n minus 1. There's 1, 2, 3, 4, 5, so it would be 5 minus 1. What does that get me? 10 divided by 4, square rooted. 10 divided by 4 is 2.5. And then the square root of 2.5, whatever that is, 1.58. That's the standard deviation for A. Okay? And what does it measure? Dispersion. It's how dispersed, on average, A is. So let's do another one. Let's do the standard deviation of B. Now B was 1, 2, 7, 12, and 13. So if we were going to guess here, would standard deviation of B be higher or lower than A? If standard deviation measures dispersion, is B more dispersed or less dispersed than A? This was A right here. It's more dispersed, right? So we should expect a higher standard deviation. Let's see if we do. All right, so how do we compute? How do we do it? I'm going to erase all this. See if we can do it. All right. So if I'm going to do the standard deviation, I first of all do, let me move it over a little bit. I first of all do the deviations, which to do the deviations, you just do each value minus the mean. What was the mean? What was the mean of this one? They were both 7. Okay, so the mean's 7 again. We'll do another one. Well, the mean's not 7, but so I take each value minus the mean. So 1, I do 1 minus 7. That goes here. What's 1 minus 7? Negative 6.
Why don't you do the placement?
2 minus 7 is negative 5. Say that again.
Why don't you do the placement? I thought that's what we were doing, not the difference between.
Yeah, it's just each value minus the mean. So we get negative 6, then negative 5, then what's next? 0. What's next? 5. What's next? 6. Okay. 7 minus 7, 0. 12 minus 7 is 5. 13 minus 7 is 6. With me? Okay. Now what's next? Square them. Square deviations. Negative 6 times negative 6 is positive 36. Negative 5 times negative 5 is positive 25. 0 times 0, 5 times 5, and 6 times 6. 36, 25, 0, 25, 36. Okay? Now let's put that in our formula. What do we do to get S, the standard deviation? Well, we do the square root of what goes on top. Total of these, right? Add 36 and 25 and 0 and 25 and 36. It's 126. Because these two are 50 and those are 72. Yeah, it's 126. Huh? Am I sure? Yes. Pretty sure. 50 and 72. Yeah, 126. 122. Thank you. Am I sure? No, I wasn't exactly sure, was I? All right. Now what's the bottom? On the bottom we do n minus 1. What's n minus 1 here? Well, there's 5 values, so that's n. Minus 1 would be 4. 122 divided by 4? Now that sounds right. I've done this before. Okay. All right. 122 divided by 4 gives me 30.5. So I'll do the square root of 30.5, which gives me 5.52. So B's standard deviation is 5.52. A's standard deviation was 1.58. Does that make sense? B's is 5.52. A's standard deviation is 1.58. Does that make sense to us? Well, it should, because standard deviation measures dispersion. The higher the standard deviation, the more dispersed. B's is higher, quite a bit higher than A's. That makes sense, doesn't it?
Is this like in pool?
Huh? Is this like in pool? Oh, yeah, like dispersing the balls, yeah. This is a, yes, I see what you're saying. These are more dispersed.
Now the 4 comes from the 4, 1, 2, 3, 4.
Yeah, there's 5 values, and so on the bottom you put 4 because you always subtract 1 for this formula.
I didn't know sure was including 0. So
Yeah, you include the 0. It just happened to be one of the values, but yeah, whatever If there had been 20 values, we divide by 19. Just one less. Okay? All right, so yeah, standard deviation. B is more dispersed. It has a higher standard deviation. Okay? All right, now let's go to another example here, if that's okay. Any other questions on that one?